Hello everyone. In this session, we'll be working on various pattern problems. At the end of this session, you will be able to solve any pattern problem under the sky. So we won't be just discussing the code for solving different patterns, but we'll be trying to find a correlation between every pattern problem and build till the end of the session, we'll build an approach, one single approach which could be useful for solving any pattern problem under the sky. So let's begin with it. So first of all, the approach which is best for solving pattern problems is using finite number of steps. So I prefer using these four steps for solving pattern problems. Initially, we won't be working with the step number 1 and step number 4. We'll be just working with step number 2 and 3. So for now, you can ignore these. Otherwise, it will unnecessarily increase the complexity for you. So let's discuss step number 2 and step number 3. Step number 2 is analyzing the number of rows in the pattern. When you are given a simple pattern, you can analyze how many rows you are printing on the screen. And that many times you can run your external loop. Isn't it simple? And after that, the only single thing left for you is deciding in which row you what to print, which will be handled by step number 3. Now, in every row, we'll try to see what are the various components we are printing. And by components, I means it might be that one single thing you are printing in every row. Let's say you are printing asterisk again and again in each row, or else it could be complicated. Let's say we are printing some spaces or something else. Then we need to handle every component. Every component means these asterisks individually, spaces individually, or let's say there might be some at the rates or some alphanumeric characters to be printed. Those could be handled separately. When we'll be discussing problems, we'll be discussing it in more detail. So that means you have to find that you have to divide the thing to be printed in every row into various character components of similar category. You have to categorize them. Then you will be handling each categorization individually by finding a correlation in each row. In words, it might seem very complicated, but don't worry. Trust me, it's really simple. So let's begin with our first problem. In this one, this is just labeling for row index and this is labeling for columns. Don't confuse this by that we have to print this as well. We have to just print these asterisks. So this is the first pattern we want to handle. How many rows we want to print? 1, 2, 3, and 4. Isn't it simple? So now what we want to do is we want to print 4 rows. So that means we'll be running the external loop 4 times. So we can say for I is equals 1, 2, 4. My bad. What we want to do in each row? We want to print stars. Now this problem is really simple. We want to print 4 stars in one row, 4 stars in second row, 4 stars in third row, 4 stars in fourth row. So we can say for j equals 1, 2, 4. What I'm saying is I want to print 4 rows. In each row, I want to print 4 characters. Now what are those characters? Those are asterisks. So what I'm saying, print 4 rows of 4 asterisks. We can say print this asterisk. So I hope this one is clear. Let's try to code this. It's really easy. We just have to write the loop for printing rows. Now why I'm saying n? Sorry, I forgot to discuss one thing. Now let's say n would have been 5 instead of 4. We could have simply replaced this with 5. So now if we want to automate this code, what we can do is we can take the input from user and run it n times. So that means for whichever value we want to perform, for whichever user input we want to print this pattern, we can simply run the loop depending on that user input variable. So let's do this one. And we can simply print the asterisk. After this, we can simply print the new line. Why I'm printing new line? Because this internal loop is printing the n asterisks in row number 1. Then I'm going to the second row. Then for I equals to, this internal loop is again printing n asterisk characters in one row. And then again we are moving to the next line. Now if you want to use it, then you will end up printing all the asterisks in single row. So let's try to run this one. Okay, my bad. Integer n, scene. Let's take the input and run it. Now we are getting the same pattern. In some problems, it might be asked to add a single space after this. Then you can add this space. In this case, we haven't. Now, if you will add the space, you will be able to see the space here. You can simply check the pattern which is given to you in the problem statement. If there's a space, you can check it by simply selecting in between the two asterisks. If there would be a space, you would be able to select it. And then you can decide on the basis of that. So let's see the second pattern where now this one is a bit complex than the previous one. We are adding spaces as well. Now it's kind of similar, but we have spaces as well. Now let's see the second pattern. It's kind of similar, but this time we are not printing the constant amount of asterisks in same row. Previous one was easier because we knew that in every row we are printing the same number of asterisks. So let's see in this one what we can do. First of all, how many rows we have to print? Step number 2 is how many rows we have to print. We have to print 4 rows. So these are the 4 rows. That means the external loop will be running same 4 times for 4, 5 times for 5. And if we have n, the user input, we can run it and print it n times. That means run the loop n times to print all the n rows. Now let's see in each row what we are printing. So first I am using row number, because for every row we are finding what we have to print. So we'll be trying to find the correlation between the row number for which we want to print and the asterisks we are printing. So let's say row number and asterisk to print. In row number 1, what we are printing? Can we say in row number 1 we are printing 1 asterisk? Similarly, can we say for row number 2 we are printing 2 asterisks? And row number 3 we are printing 3 asterisks. Similarly, for row number 4, we are printing 4 asterisks. So, is there any correlation? These values are identical. So, that means we can say we are printing I stars in each row. So, we can say for j equals 1 to I. Rest everything is same. Instead of n stars in each row, we will be printing I stars in the ith row. Then you can similarly say print star. Let's code this one. Nothing else. You just have to change this n to I and it will work. Now we are able to get the proper triangle print. Let's check it for 5. We are getting it right. Let's check it for 3. Now you would be easily able to see that approach is same in first as well as in second. Now in third one also, this one we won't be discussing in too much detail because it's exact same pattern as this one. But the only thing which we have to discuss is that instead of asterisk, we are printing some numerals. So let's see. It's almost same. The only difference is that row number and numerals. We are printing some continuous numerals starting from 1 in each row. Then we are going till 1 in some row, then till 2 in other one, then in till 3 in the next one, then till 4 in the fourth one, so on and so on. It's very easy to visualize it that in row number 1 we are printing till 1. In row number 2 we are printing till 2. We can, instead of saying numerals, let's say printing numerals till. In row number 3, we are printing numeral still. In row number 4, we are printing numeral still 4. In row number 5, we are printing numeral still 5. Similarly, if we would be having row number 6, in that one, we'll be printing, my bad, numeral still 6. So that means, first of all, if we have user input as n, if we would be given user input as n, we have to print n rows. So that means in this one also it will be almost, this thing will be exact same. We are saying for I equals 1 to n. That means we want to print n rows. Now what we want to do in each row? In each row we are printing in numerals till I. So that means we want to print one character in first, two characters in second, three characters in third row. So there's a correlation between the number of characters we are printing in a row and the row number. That means the number of characters we are printing in our row are exactly equals to I. This is similar to the previous one. So we can simply say for j equals 1 to I. But the only difference is instead of printing asterisk, we have to print 1, 2, dot, dot, dot till I. So we can say print j. Let's change the previous code and make it compatible for this problem. Okay, let's say printf modulus d, let's say print j. Let's build this one. Now we're getting correct output. Let's make it for 5. It's working. So let's try to move towards bit complex problems. Now the next one is, now this is the first problem in which we will be printing characters as well as spaces. That means we will be printing two things. So let's say row number 1, row number 2, row number 3, row number 4, row number 5, row number 6. I forgot to mention user inputs in the above patterns, but you will be given a user input is equals 6 in this case. Although we have already discussed the input thing I have discussed, I didn't just mention above. In this one, I am mentioning also so that you have a clarity about it. I hope I didn't confuse you in the previous ones. So now we have a user input equals 6. Let's see how many characters we are printing in each row. We are printing 6 characters. Now first thing is step 2 is very simple. How many rows we are printing? N rows, user input is 6, we are printing 6. Let's say user input would have been 4, we would have been printing 4 rows. And user input, if it would have been n, we would be printing n rows. So depending on the user input, we'll be printing those many rows. And we can see the number of characters are also same. This kind of problem would always be that print n into n grid depending on the user input. So in this case, your user input is 6. So we are saying for I equals 1 to n. We want to print n rows. In each row, how many characters we are printing, first of all? Same number of characters. This problem would always be 6 into 6 grid or 8 into 8 grid or 4 into 4 grid. The problem would have clearly specified to you that print an n into n grid. So that means we'll be printing n characters in each row. But the tricky part is that we want to print asterisks as well as spaces. Now, till now you were given only one type of characters. This time you are given two different type of characters. So let's say row number, let me move these both components. Row number, then let's say asterisks, and then spaces. Now let's see. First of all, row number 1, then row number 2, then row number 3, then row number 4, then row number 5, and row number 6. Now, Can you see that in first row we are printing asterisk at every single position starting from 1 till 6. So we can say print a star everywhere. Similar thing for row number 6, we are printing a star everywhere. Now in spaces, no spaces in row number 1, no spaces in row number 6, because at every position we are just printing asterisk. If you will visualize it, in first row we are printing asterisks only at every particular position. Similarly for row number 6, but for row number 2 till row number 5 we are printing asterisks at just last positions. So that means we have to print asterisks at first and last column only. Now, although I'm discussing it with every single row, but the better approach for solving this one is just visualizing it and deciding which rows or which particular columns you want to print the asterisk. You will simply look at it. First row, you are printing asterisk everywhere. Last row, you are printing asterisk everywhere. First column, you are printing asterisks everywhere. Last column, you are printing asterisks everywhere. So we can write it this way also, but it will be more complex to discuss or to understand for you people only. We can say first and 6. In row number 2, we are printing at first and 6 column. Same for this one. Let me copy paste. First and 6 column. First and 6 column. First and 6 column. So first and 6 column means first and the last column. So you can do it this way as well. And spaces we are printing at 2, 3, 4, and 5. Now, if you will look at this, although you can simply deduce this is not a very complex pattern. You can deduce this by just looking at the diagram as well, that we are printing star for first row, last row, first column, and last column. So that means at every position in first row, last row, first column, and last column, we are printing star, and we are printing white spaces at all the remaining positions. So can we say if we are in first row, if we are in last row, or if we are in first column, or if we are in last column? If we are at any of these 4 positions, print a star, otherwise print a white space. So let's try this approach. Okay, one second, let me write it here first. So what we are saying is, if my bad. If what I'm saying is, if I is equals 1, or I is equals n, or j is equals 1, because I'm using I variable for the row number, j variable for the column number. If or j is equals 1, or j is equals n, then print a star. Else, in this case, we'll be printing a star. Let me write it properly instead of simply writing star. Print star. Else, print a space. Now let's code this one. It's really easy. After taking the user input, what we have to do is, for integer I equals 1, I is lesser than or equals n. That means these are the number of rows we have in our pattern. Then we counted the number of columns as well. For integer j equals 1, j is lesser than or equals n, j plus plus. These are the number of columns we have in our pattern. Then we have a simple condition that if I is equals 1, or I is equals n, or j is equals 1, or j is equals n. If any of these are true, then we have to simply print a star. I am adding a space as well, but in your case, you will be checking the pattern which is given to you. Depending on that, you will be deciding that you have to add an extra space or not. But always remember, if you are adding an extra space after this, yeah, then you will be adding an extra space after the space as well. Okay, let's not complicate it. Let's keep single space for the space and no space after the asterisk. Let's check, is it working or not? Okay, my bad. Now this was the thing which I warned you multiple times, that add a new line after it. Otherwise, you will end up. Now this is, they are printing this asterisk in all the asterisks in same line. So the thing is, now they are printing all the asterisks in same row. Just the thing is that because the space is not enough and Sublime automatically sends the remaining portion to the next line. That's why we are getting it in multiple lines. But since we are adding no new line, so we are not getting any new line character added, because of which everything is printed in a single row. Don't get confused. Now, by adding a new line, we are getting a good looking rectangular, not rectangular, square pattern. Although it looks like a rectangle, but it's n into n asterisks. So it's kind of square only. You can try as smaller or as larger you want. It's working fine. So let's move to the next topic, which is patterns, where we'll be running multiple internal loops. Now let's see this pattern, which is known as pyramid. This is a very famous pattern, which is pyramid, as it's visible from the look only, because it looks like a pyramid. That's why we call it. This is our pattern. These are the number of rows. These are the number of columns we are printing, because the maximum characters we are printing are, let me shift it by one space. 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the maximum number of characters we are printing. So that's why I'm saying that there are 9 columns. And let me add something for white spaces so that you can visualize it better. 1, 2, and 3. 1, 2. Okay, my bad. It's 4, 3, 2, and one space. Okay. Yeah. So this is the pattern. I'm just adding these dots to indicate to visualize white spaces, because otherwise you won't be able to see how many white spaces we are adding. So let's see how we can solve this type of problem. First of all, the steps we have already discussed, that there are 2 steps to solve any pattern problems. How many? Now in these questions I will be asking you to think. So please try before listening to my explanation. Try to visualize that how many rows you want to print or whatever I will be asking. How many rows? Think about this. How many rows, and write the pseudocode for the external loop. We are, if you want to take some time, you can pause your video here. Otherwise, I'm continuing with the explanation. Now it's clearly visible that we are printing 5 rows. So how many times we'll be running the external loop? 5 times. Sorry, my bad. I again forgot to write the user input is equals 5. Now, if user input is 5, we are printing 5 rows. Now, we'll be, because for the sample case which we are discussing, we can take only one user input. That's why we write it this way. Don't get confused that user input will be 5. User input could be anything. We are discussing just one sample user input. Let me write here. Sample user input is equals 5. And for 5 sample user input, we are doing this. If this would have been something else, let's say this would have been 4, then the rest of the pattern would be same. This last row won't be added. If the pattern would have, user input would have been 6, then there would be another row with similar approach. With the same approach, another line would be added below this. Then one more white space would be added before every preceding row, one up before this, two before this, three, four, five. And then for this one, there won't be any space and there would be 11 characters in this one. So let's see for sample input. And if you might be confused that why 11 characters for the sixth row, you will be able to visualize that as well once we discuss the approach for this one. So how many rows we are printing? 5. That means how many times the external loop will be running? 4. Let me write it this side. 4 I equals 1 to 5. That means for n equals 5, for sample user input equals 5, we are running it 5 times. For user input 6, we are running it 6 times, because those are the number of rows we are printing. So we will be saying we'll be running it 10 times. Now let's see what are the various components we are printing. First of all, row numbers. Let me mention the row numbers here so that you can view them side by side easily. These are the row numbers we are printing. After this, what else we want? Sorry, these are the row numbers which we are dealing with. We are not printing it. We will be printing two things. One is spaces and another is stars, or as you can simply draw it. Let me write it this way. Stars, or this star character. So in first row, how many spaces we are printing? 4. In second row, how many spaces we are printing? 3. In third row. Now, all these things we are doing just for computing our performing our second step for the process. Oh, sorry, third step for the process. First and fourth, we are not working on them for now. In this, from this pattern, we'll be starting with the first and fourth step as well. We'll be performing all the four steps on this pattern, but till now we are performing second and third step only. Second step is always how many rows, which will be decided, and then according to that, how many iterations for the external loop. It's better to say how many iterations for external loop. You will be visualizing the rows in the pattern given to you and deciding on the basis of that how many iterations of external loop. Now this is all for deciding what are the internal loops we are running and what will be the number of iterations for them. Now after this, in next row, sorry, I messed it up. In next row, we'll be printing one space, and in the last row, we'll be printing 0 space before that. And don't worry about these spaces. You might be thinking that there's something else we are printing after this. We can simply move to the new line. Don't confuse that. I'm saying 9 because this is the diagram, but I think I messed up something. It should move one place. Okay. I'm saying 9 because these are the 9 asterisks in this one. In these ones, there are spaces, but we don't need to bother about them because after this also there's white spaces only. So we can simply use a new line character and keep the whole row as white space after this. So let's see what's the pattern for stars. In first row, we are printing 1 star. In second row, we are printing 3 stars. And it's always like this. For the third step in your process, that means computing the number of characters you are printing in internal loop. You will be writing these characters. Sorry, it's 7. If you will count, there are 7 asterisks and then 9 asterisks. And based on these, you will try to compute a variable. Till now also, we were doing the same thing. The only thing is now the complexity is rising a bit. Now we try to find a pattern in the number of characters we are printing in each row and get a single variable so that we can build a loop using that single variable and perform iterations for every single row by using that single variable. So let's see. In first row, we are printing 4 spaces. Second row, third. Third row, 2. First row, fourth row, 1. Fifth row, 0. Can you find a pattern between the row numbers and spaces? Okay. So let's see. 1 plus 4 is 5. 2 plus 3 is 5. 3 plus 2 is 5. I'm giving you another way as well. You might be thinking that how we'll be able to deduce that we have to focus on this thing. 4 plus 1 is 5. 5 plus 0 is 5. So it's 5 for every row. First, I'm giving a non-mathematical approach. We'll come to mathematical approach as well, where you don't have to build the logic by yourself. Now in this case, it's row number for which we'll be using I variable because I variable is indicating the ith row. For row number 1, the I will be 1. For row number 2, I will be 2. So we can say row number for I. So, and we'll be using a J loop for spaces. We'll use another loop. J variable will be indicating the number of spaces we want to print. Let's see how we can find a variable value for these spaces printed in ith row. Can we say I plus j is equals 5? That means when I am in ith row, I will be printing. Here I am in, when I'm saying j, I'm simply saying, or let's say, let's not say j, let's say spaces. I plus number of spaces, or you can say c spaces, that means count of spaces. Let's simply say cs to make it a bit simple. Cs, that means count of spaces. I plus count of spaces in the ith row is equals 5. Now we can deduce from it, we can say count of spaces is equals 5 minus I. Now here 5 is the sample user input, that means user input will be n, and here also we can say I plus cs is equals n, that means the row index or row number plus count of spaces will be always equals to the variable n, and using this we can formulate this equation. Now we can say for spaces the loop will be for j equals 1 to how many spaces we want to print? We want to print n minus I spaces, where n is the user input and I is the row number. Now the other approaches that might seem confusing to some people, that how we'll be, because it won't be always this pattern. In some other pattern, it might be slightly different the way to build this. So what you can do is, if you will simply look at this pattern, it's a simple arithmetic progression. 4, 3, 2, 1, 0. It's simply an AP. So can we say an is equals a plus n minus 1 into d. Now don't confuse these this n with the n which we are using till now. I'm changing it. Just give me 2 minutes. Let me write a capital N so you don't get confused. Now we have studied this formula in arithmetic progressions, that an equals a plus n minus 1 into d. Those who are confused that what is arithmetic progressions are simply sequences with a common difference between them. Now this is a sequence with a common difference between them. 4 minus 3 is 1, 3 minus 2 is 1. So it's decreasing by 1. Every next term is decreasing by 1. So it's a AP with a common difference minus 1. So let's see how we can compute from this. An is the, now we can, instead of saying an, we can say AI. That means what will be the number of spaces in ith row. So we can say AI is equals, now A is 4. So can we, now A is in first row, we'll be printing the spaces n minus 1 spaces we are printing in first row. So we can say n minus 1 plus, now this n is the same which is given to us. If this seems confusing to you, you can use the earlier approach, plus now we can say, now when we are saying n minus 1, this n we can replace it with I because we are finding AI. So we can say A equals A plus I minus 1 into D. That means the ith term of the AP will be A plus I minus 1 into D, which is simply arithmetic progressions formula. You can revise this formula if you are confused about it. Now I minus 1 multiplied by D. Now D means the common difference. The common difference is minus 1. It's decrementing by 1 every time. Now we can use this formula to build our answer. AI is equals n minus 1. Now minus 1 will be multiplied by the I, so it will become minus I. Minus 1 into minus 1 will be plus 1. Now this plus 1 and minus 1 could be cancelled. So we can say AI is equals n minus I, which is the same which we are saying here. So we can say the number of spaces in each row will be determined with the help of n minus I. Now let's look at stars. 1, 3, 5, 7, and 9. Now again, if you want, you can use the arithmetic formula as well. Arithmetic formula, I won't be discussing it in too much detail. I will simply use it. AI is equals A, which is 1, plus n minus, because whatever pattern you will be, whatever user input you will be having in first row, you will always be printing one star. In this case, we were not using 4 because depending on the number of rows, this spaces will decrement or increment. If the size of this pattern, if the user input will decrease from 5, this pattern, these number of white spaces will start decrementing, because this one initial column will be completely removed from it. So one space will be reduced if this 5 will decrement to 4. Another one will be reduced if this will decrement to 3. So the white spaces will be variable. For the first row, the white spaces will be variable depending on the user input. But the asterisk is fixed. It will be 1, be it for 5, for 6, for 7, for any n. So that's why here we are not using a variable, we are simply using 1. So we are saying 1 plus n minus 1. Let me add it inside brackets, multiplied by the common difference. Now the common difference is 3 minus 1 is 2, 5 minus 3 is 2. So we can say 2. So I'm simply deducing it, 2n minus 1. You can uh, solve this equation and get this 2n minus 1. I'm directly doing it 2n minus 1. Now the other way for this is, if you don't want to use the arithmetic formula, you can simply visualize these values and find a pattern. For first row, 1 star. Second row, 3 stars. Third row, 5 stars. Fourth row, 7 stars. Fifth row, 9 stars. So you can simply see that the number of stars are 1 lesser than double. So that's why we are saying 1 lesser than double of n. That means double of I. Because for every ith row, we are saying 1 star lesser than, sorry, my bad, I used n here. Oh, yeah. So why we are using I? Because for we are finding the AI, we are not finding AN, we are finding the stars for ith row. So we can simply say this. So that means this loop will be printing the space then we'll be writing another loop nested inside the outer one. Now you can use the j variable also, because this loop is already terminated. So we can say for j equals 1 to 2i minus 1 print star. And then after this you can add a new line, because once you have printed spaces and stars, now you want to move to the next line to print the next row. Yeah, I hope this one is clear. So let me write the code for you people so that you can get an even better idea. So we can say for integer I equals 1, I is lesser than or equals n, I plus plus. These are the number of rows we want to print. For integer j equals 1, j is lesser than or equals. Now how many spaces we want to print? We want to print n minus I spaces, j plus plus. We can simply say now how many stars we want to print? We want to print 2 into n minus 1 stars. Sorry, not n. 2 into I minus 1 stars, j plus plus. After this, we can print a new line character so that we can move to the next row. Let's check it. First, let's check it for 3. Now we're getting it correct. Let's see for a bigger variable. Let's check it for 6. We are getting it absolutely fine. Now let's see the next pattern. Now this part is very interesting. Now we will be implementing the step 1 and step. Oh, now we'll be implementing the step 1 and step 4. Now, if you will look at this pattern, this is the same which we printed just now. So we can use the same code. Now, if you will look at this pattern, this is something same as we printed already. The only difference is now it's in reverse. And second thing is 1, 2, 3, 4. These 4 rows we are printing in reverse. If you will count, if we replace this row, then you will see that this first half and the second half, this part is exactly identical. The only difference is it's printed in reverse. Let me add the row which I removed again. So can we say we'll be using same code just in reverse, and we won't be printing this nth row. So that means, let me bring it from here only. Okay, I can't. So 1 second. 1, 2, 3, 4, 5. These rows we can print the same way we printed in the previous problem. Then for these rows we can say 4, 3. That means these, for printing this second half of the pattern, we can simply print the fourth row, third row, second row, first row again using the same approach. So can we say this pattern is repeating something twice? This first half and second half. And please never get confused between this thing that this first half, because you might think that vertically also the first half and second half is same. But always remember, can you return back once you printed this first half vertically? Can you return back to the first row? No, that's not possible. So we'll never divide it vertically in this way. We'll always divide horizontally. So let's try to reverse it somehow. Can we simply reverse the external loop? Now what we are saying is that reverse this to print the second part. If we copy the same code and reverse the outer loop, instead of starting from 1, we start from 4 because we want to print 4, 3, 2, 1. 4 means we start from n minus 1 because we don't want to print the last two. Now let's see, can we copy the same code and reverse the problem? So now I'm implementing step 1, and if you will try to think about it, I'm implementing the step 1 and step 4 because I divided the problem into two parts, first half and second half. And in the fourth step, what was the fourth step? After solving the first half, because we have already in the previous problem we solved the first half of this problem. Now I'm trying to use the same code to solve the second half. Instead of starting from 1, I'm saying start from n minus 1. Now this is the same copied code. I is greater than or equals 1, I minus minus. Nothing. I copied the same code. First half I use the same code. Second half I use the same code by, oh, sorry. Now let me see that do we get the reversed pattern as well or no. We are getting it. Now we are getting the exact same pattern which we wanted for this first half. We use the code. This is the same problem which we have already discussed. We use the same code. Then this, for this half also, we copied the same code which we used for the top part. We use the same code for the bottom part as well. So just reverse the loop and started it from n minus 1 because we don't want the nth row. This is the only change. The rest everything is same. So isn't it fun? This diamond problem, if you would have directly approached it, you might have thought that it's really tough problem. But it's nothing else than printing the pyramid code twice. First time in normal order, second time in reverse order. So I hope this is fun. Now let me show you a really tough pattern problem, which we'll be discussing the next session. Try to have a look at it. Try to decode it. Now I have used some numeral labeling. You can use it as a hint. In next session, we'll be discussing this as well. So I hope you were able to understand the 4 steps as well. Let me show you the steps again so that you can correlate it with the topics we discussed. First step was dividing the pattern, which will be required in those problems only where you can divide the pattern into various identical components and working on each component individually. But always remember, dividing the pattern into various identical components horizontally, not vertically. Then, second step, we worked in multiple problems on this step, analyzing the number of rows in the pattern and deciding the number of iterations for the external. So, for every pattern, the most easiest step was looking at how many rows we are printing and running the external loop those many times. Then the third step, which was the most complex one, analyzing a pattern in the various characters. Then for every row, we would be analyzing that what are the character combinations we are printing in it, and we'll try to derive some variables so that we can use those variables for the looping. We'll try to find what is the correlation between the row number and the number of character times we are printing a particular type of characters, and by finding the correlation we try to derive a variable using which we could run the internal loop to print those characters for every ith row instead of printing it manually for the every row, printing it individually for every row. We'll try to find a variable and automate it that for every I print these many times. Then the fourth and final step, trying to find the correlation between the first component of the pattern. That means this is only for the problems of this type. For these, we'll be discussing this problem as well in the next session. Sorry, I forgot to mention this one. I hope this you should be able to solve this one. This one is really easy. Try to solve this one as well, and try to have a look at this one as well. Try to draw this pattern, try to think about it, and I expect this one should be really easy for you people to solve. It's just reverse of what we did in this one. Now for these type of problems, for this one and for this one, we are, oh my bad, we are using this, where is it? Okay, yeah, it's here. We are using this fourth step at last, that trying to find a correlation. Now even if in this one you will look at it, we have the correlation. Now again we are printing this part. You can simply say first row, second row, oh my bad, third row, fourth row, fifth row. Then again we are starting with, although this is the sixth row, but can we say that use the same logic we used for the fifth row? Use the same logic which we used for the fourth row. Use the same logic which we used for the third row. Use the same logic which we used for the second row. The same logic which we used for the... So can we say it's simply the reverse of the first half? So try to write the code for the first half and then simply you copy and paste that same code and just reverse the external. Try this one and this one. I hope session was fun. You were able to learn. Please, if possible, note down these 4 steps. Try to implement in these 4 steps in every possible pattern problem, and you will be able to see that these 4 steps help you solve every pattern problem under the sky.